Hello friends, welcome back to my channel, and today we are going to discuss about further advanced techniques about chunking, data chunking in RAG. So let's have a recap quickly. So we started with this RAG session, so data collection techniques, and then data reorganization, then data cleanup, and then we started with two to three simple RAG techniques, and now this is going to be continued here. So we are going to talk about sliding window data chunking and recursive character splitting in RAG. Okay, these are the two little advanced techniques we are going to discuss. So let's get started. By the way, before we start the video, so the entire source code is available in the GitHub, and the link is in the description. And to start this chunking, we are going to use a typical PDF file from where we will fetch the data, and then this data is basically some e-commerce microservice architecture. There are a couple of microservices. There is a documentation. So if you see, there is a diagram, there is a table, there are paragraphs and text, and a lot of other info is there. So this will be interesting to use as a input for chunking. Okay, so let's get started. Right. So data chunking. So just introduction. It is a critical processing step of splitting large documents into smaller, manageable, and semantic pieces. This allows the retriever to effectively find relevant information and fits within the LLM's limited context window, improving accuracy and reducing hallucination. Okay, so what are the key aspects? Once again, I'm repeating purpose. So it ensures high quality retrieval by breaking down data into meaningful units, allowing the system to focus on specific information rather than the entire document. So basically, this is the data chunking advantage. Strategies, yes, different strategies. Yes, so common method include fixed size chunking and sentence based chunking. So here we are talking about the additional two strategies, which is the sliding window and recursive character splitting. Overlap, again there will be overlap of text between chunks, so which is useful in one way, uh, although it will increase some processing steps, but yes, it is going to improve impact. So poor chunking leads to irrelevant and fragmented or missing information, and will have a lot of negative impacts. That is why we need to always look for the advanced chunking techniques. Okay. Recursive character splitting. This is the technique we'll see today. It splits the text based on the hierarchy of separators. For example, paragraph, then sentences, and then words. So paragraph typically will have two new line character. A sentence probably will have a space, and the words will also have space. Or sentence will have one new line character sometime, and so on. This technique optimizes RAG by ensuring document snippets remain semantically coherent while fitting within the model's context. Okay. So recursive character splitting. So it is done by it works by prioritizing the structure. So it attempts to split text using hierarchy of delimiters. Okay. So two new line character, one new line character, or the full stop where the sentence will end. So if you see this data, sample data, so if you see after, let's say, after this full stop, there is a new section started. So basically, a new paragraph we can consider. After end of this, there is a new paragraph. So there can be two new line characters. Okay, after end of this text, after end of this, there is a new paragraph. Okay, new section started, right? Uh, Right. So if you see this, after this, there is a not new section because the section started here. The section new section is here. So this entire is one section, and it is divided by, let's say, sentences within with one new line character. At the end, there is a new line character. Okay, and there is a full stop also. So let's take some other example where we have multiple sentences. Okay, let's go to the top. Yeah, so if you see, this is one sentence which is at full stop, and this is a second statement, second sentence. So those are divided by one full stop. Okay, right. So this is one technique where we prioritize the structure, then maintaining context. So by splitting at paragraphs or sentences first, it keeps related ideas together, preventing the cutting in the middle of a thought issue in the fixed size chunking. right? So we have seen the fixed size chunking where we will only cut the chunks with, let's say, only 500 characters every time. So there might be loss of some context or loss of some data. So that is the advantage here. Okay. Improving retrieval, so high quality meaningful chunks lead to better vector embeddings, okay, which increases the accuracy of the similarity search when the system retrieves the data to answer a prompt, right? Handling overlap, so it often includes a buffer overlap so between chunks to ensure context isn't lost at the boundaries, helping the LLM to synthesize information across adjacent snippets, right? So there is a slight overlap, okay, and we will see that in the coding example, and it is mostly necessary to avoid the loss at the boundaries, okay, loss of context at the boundaries, okay. Mixed format documents, uh, right? So top places where this particular techniques is a must, okay. So let's say mixed format document, so that is what we have seen. We have a PDF where we have mixed formats, right? We have very mixed formats, so text is there, image is there, and there is a table also, right? So it's a different format, different formats. So when your data set contains a variety of structures, for example, long form articles, bullet list, short blurbs, image, tables, okay. So simply if we do go for fixed size splitting, then that will not help. Technical documentation, yes, we have seen the technical documentation. Manual or API docs where keeping a paragraph train of thoughts together is necessary for the LLM to provide accurate instructions. Apart from this, let's say there is some legal document or medical research paper, unstructured web scraps and whatever other examples. So there also, this is a must. This technique is must, right? So let's see a demo. Okay, so this code is there available in the GitHub. So we have recursive character splitting. So here there is a, we are using LangChain community and a recursive character split, recursive characters text splitter method from the LangChain text splitter. Okay, so the same documentation file I am using, it's a docx. We can use a PDF also, and yeah. So I have to specify the chunk size and the overlap. So let's say this is a fairly large document, so I'll chunk every 500 character, and there is a overlap of 50 character between two chunks, and these are the separators. So new it's a paragraph or a line or a sentence or a word, and maybe you can have a dot which is a sentence overlap. So I'm using these 3 4, but we can go for other also, right? So then split the document, so we will have chunks, okay. We will print how many chunks we got, and then we will we will preview the first three chunks, right? Okay. um, okay, so processing is done. Okay, processing is in progress, right? So we have seen, as I said, we are just seeing the three chunks, but there are how many chunks? There are 10 chunks totally found, okay. Out of this, so if you see, this is printing the metadata of the particular individual chunk, then the context preview and the actual chunk, okay. Yeah, context preview, okay. Same thing for the second, yeah, same thing for the third chunk, and so on. Okay, so this is one way to uh, have a chunking of the input data. Now, being from the automation or from the manual testing or from the automation side, or from the testing background, let's say somebody developed this. Okay, now we want to verify that whether it is working, and then the chunks are actually getting created properly or not. So if you do it manually, we can do it for one or two, or maybe 5 to 6 chunks. But if the documentation is huge, then it makes sense to do it automatically. So I'm using the similar items here, but I'm doing the automated validation also, okay. So same thing, I'm splitting it. This is the development part where I'm doing the splitting the document, and then validating the chunks. Okay, so here what are the parameters to chunk to check that the recursive character splitting is working properly. So we will do a size check. Okay, then if it is success, all chunks are within the size, and we'll rejoin the chunk and we will check the content integrity. Okay, because we are splitting one document into, let's say, 10 chunks. Right here we have seen there are 10 chunks found. So simply what we'll do, we will club the 10 chunks and we will see that, okay, whether the integrity is correctly working or not. Okay, um, otherwise there will be some missing words. Okay, then we will see the overlap. Okay, so content flows correctly between chunks, right? So we have seen that there is a overlap of 50 characters. So accordingly we have to verify whether the overlap is working properly or not. Okay, so get the last 20 chunks of chunk 0, get check if they exist in the chunk 1. Okay, consecutive chunks. Then uh, tables. Okay, so tables, are they broken or are they preserved properly or not? So we will see that. Okay, so it's a good exercise to see overall the uh, um, recursive character splitting is working properly or not. Okay, so if you see here, we have so many chunks. Okay, now all chunks within the size limit. Okay, which is fine. Chunk content integrities, all core technical terms are preserved. Okay, then table preservation, so no isolated table or pipes found. Fine. uh, Overlap warning, so context tail of chunk 0 not found in chunk 1. Okay, so context and tail of chunk 0, so this is the chunk 0 and this is the tail at the end, and that is not found in the next chunk. Okay, so this can be something which we can look into, that why this is failing. Okay, so here I have just specified a sample validation technique, and of course there are chances to improve on it. It's not hard coded, it's not fixed approach, but one approach is there, right? Okay, so now let's proceed for the next technique, which is the sliding window. Okay, right, so we'll see the sliding window now. Sliding window overlap. Okay, sliding window chunking or overlap chunking. So here each chunk includes a small percentage, let's say 10 to 20% of the previous chunk. Okay, this ensures that context at the edges of a split is not lost, which is a critical or which is critical for narrative or legal documents. Okay, we'll see a legal documentation, I mean some documentation example, and it prevents the context fragmentation. Now there is a slight um, similarity of sliding window chunking and recursive character splitting. Okay, and there are differences, so we will see that accordingly in the next slide. Right, so sliding window chunking, so where this technique is must. Okay, again it's a question of debate, but let's say legal contract analysis, medical transcript processing, financial report, market reports, and technical manuals and documentation, so similar to what we see in the recursive character splitting, but yes, we will have to explore this also. Okay, let's see a demo and automated QA. So here also I'm using the same recursive character splitting, and here the chunk size is 1000 and the overlap is 200. In earlier case it was 50, but now it is 200. Okay, and again similar techniques for separators, right? Okay, so same thing here as we did in the recursive character splitting, almost the same thing, but some parameter changes. Okay, right, so there are some changes, and here I'm using a different PDF, which is a GDPR, um, uh, basically some legal documentation I'm testing. Okay, now the chunking is done. Okay, now we need to automatically validate whether the chunking is happening properly or not. That is why this QA part. So in the QA part, again same thing, I'm using the same PDF. The chunk size is 1000 and the overlap is 200. I'm reading the PDF and splitting it based on the separator and the standard parameters. Strip white space equal to false ensures our validation comparison doesn't fall on spaces. Okay, right? So sometimes there will be one space, two space, or depends. So to avoid that, we are skipping it. Then, right, so run the implementation, and we are running the implementation. Right, so here we are doing the PDF processing first, then we'll see the how many chunks are found. Then we will have a kind of a tabular structure to represent the boundary, status, and match content. And so we take a 50 character sample from each set of n, chunk n, and check if it exists anywhere in the start of chunk n plus 1. Okay, so that is the sliding window common part, that we will see from one chunk to another chunk whether it is present or not. Okay, right. So this is one way, one technique to validate the sliding window. There can be other techniques also, but let's see this technique. Okay, so if you see here, this worked quite good. Okay, so almost everything is passed. Okay, so yeah, 462 out of 462 boundaries are intact, right? So uh, this way we can validate the sliding window chunking technique. Okay, right. Now let's see the difference, as I mentioned earlier, difference between recursive and sliding window. So focus, so in the recursive, the focus is on structural integrity between sentences and paragraphs. Here it is basically continuity across the boundaries. Okay, so as we have seen in the window, if you see, these are the chunks, right? So the whatever is there in the boundary part between two chunks, that is what matters in the sliding, but in the recursive it's a different approach. Okay, splitting logic, here it is based on the two new line character, one new line character, and so on. Here it can be fixed character or some token chunks. Okay, but in our example we have also seen the same splitting logic in the sliding window. Okay, overlap, so here it is overlap is optional, separate configuration. Here it is, that is the core, because without overlap the sliding window is of no use. Okay, so it is a fixed step. Here it can be changed, or it is optional. The resulting chunk size, it is variable, and in the sliding window it is fixed. Okay, this may vary based on the splitting logic, but here it is fixed. Right. So now let's see a bonus part. So we have seen so far the uh, text-based chunking. Okay, so let's apply this to some other techniques. For example, sliding window for image processing. This is interesting because apart from text or audio, which is again converted to text, we are going to see one more thing called as image processing. Okay, so spatial overlap. One example, spatial overlap. So a fixed size window, for example x into x pixel, slides across a high resolution image like a large blueprint or a map. By using 10 to 10% overlap, 10 to 20% overlap, an object at the boundary of window A will appear fully in window B. Okay, this is blobbing technique or multiple spatial overlap technique, which is very widely used for object detection in images or videos also. Okay, so I have a slight video for this, and let's see for this. So if you see, this is some view is there, some scene is there, and there is object detection going on. So there will be one sliding window here, and it will scroll 10 pixel here. So it's a basically splitting this technique, sliding window technique, where it will go to the next slide, but it will contain the pixel which are earlier, which are from the earlier frame, and so on. So like this, it will go to every place, and it will find out the relevancy and detect the object. Okay, so it went and overlapped the pixel of the earlier frame into new frame and then continued. Okay, right. So this can be useful this technique can be useful for this spatial overlap identification object detection to avoid any kind of a loss, right? Okay, so right, so that's how we can use these chunking techniques and to automated testing of the same. Now if you like this content, please like, share and subscribe to my YouTube channel. Thank you.